Hi, so today's question is from the official SAT study guide, and it is practice test 2, the math calculator number 23, someone asked about. All right, so number one, it said questions 22 and 23 refer to the following, and remember, we always want to go from the arrows. We don't want to stop and think that a question's done with that equation, and make sure that we're using that equation for both problems. But okay, so we have this equation, I equals P divided by 4 pi r squared. And so I said at a large distance r from a radio station, the intensity of the radio signal is related to the power of the signal by the formula above. All right, so it says for the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity of observer B. So I actually said that the intensity of A was 16 and the intensity of B was 1, because that's 16 times as great. So in thinking about that, if I worked with the equation, what I'd actually get would be 16 equals P over 4 pi r squared. And for the intensity for observer B, I would get 1 equals P divided by 4 pi r squared. All right, well, noticing that the 4 pi r and the 4 pi r, they're the same factors, I can actually get rid of them. They don't really matter because they are the exact same. They're not going to change 1 and 16 by any matter, but it's that r squared that I have to think about. So in this equation, I had 16 over equals 1 over r squared, and I got 1 equals 1 over r squared. So multiplied both sides by r squared, and I got 16r squared equals 1, and I solved. So I divided by 16, and I got that r squared was equal to 1 over 16, so r was equal to 1/4. Where if you do that same thing here, you're going to get r squared equals 1, and r equals 1. So if you ask, it's saying the distance from observer A to observer B is what fraction of the distance from observer B. And r is the distance from the radio station, so it's 1/4. And it's kind of similar to what you might have learned in geometry when you were talking about ratios of areas and scale factor. Where they had a different scale factor depending on the ratios of areas was different because you're multiplying by a square unit. And this is also could be even considered like when you did joint variation, inverse variation, direct variation. You did similar questions to something like this. All right, guys, hope that was helpful.